question 7.1, the first thing that we're going to do is we're going to be given an expression that's got some x's in it, and then it's going to give us different numbers it wants us to plug in for those x's. So like on number 1, you have an expression that says 8x minus 2 over 7x. And then it wants you to find 2 different things. It wants you to find what would this be if x was equal to 2, and then what would it be if x was equal to -3. So it's kind of like 2 problems in one. So let's do x equals 2 first, which just means I'm going to come everywhere I see an x, and I'm going to put in a 2 and then just do the math in the top and the bottom. So up top, I would have 8, replace that x with a 2, minus 2, over 7, and replace that x with a 2. And then just do the math that we have. 8 times 2 gives me 16. Just bring over that minus 2. Over 7 times 2 is 14. So I have one thing left to do up top. 16 minus 2 gives me 14. And I still have 14 in the denominator. So since you have 14 over 14, you would simplify it to 1. So again, we're just going to replace the x's with whatever number it tells us it wants x to be, and then do the math. So on number 1, it also wants me to replace the x with a -3 to see what that would do. So again, it's going to be the same problem everywhere I see x's. So in these 2 spots where I put 2's, this time I'm just going to put -3's. So I have 8 times -3 minus 2 over 7 times -3. Eight times -3 gives me -24. Just bring over that minus 2. Over 7 times -3 is -21. Now remember, I have left up top, I need to do -24 minus 2. And don't feel bad if you want to just put that in your calculator. -24 minus 2. Right? You don't want to get this far and make a mistake there, which gives me -26. Bring over the -21, and then if you're not sure if that reduces, then remember, you can also put that in your calculator. So just put it in exactly like you see it. -26 divided by or over -21. Now remember, when you hit enter, it's going to give you a weird decimal, but remember how we turn our crazy decimals into fractions is we just hit the math button and then hit enter twice. So it doesn't reduce, but look what it did do, right? Because it was a negative over a negative, it did turn it to positive 26 over 21. Okay, we're going to do the same thing on number 2. So number 2, we have -3x in parentheses squared over 2x plus 8. The first thing it's going to want us to find is what is this when x equals 4? So in these 2 places where I see an x, I'm going to replace those with 4's. So up top, I still have the parentheses, -3 times 4 squared. In the bottom, plus 8. Now remember, we need to do before this exponent, I need to do what's inside these parentheses first. -3 times 4 gives me -12 squared. Okay, we can just go ahead and keep on simplifying the top. Let's see, -12 squared. This brings up something I do want to remind you of. In your calculator, when you are squaring a number, especially if it's negative, if it has negative around that -12, parentheses around that -12, you need to tell your calculator that, right? So you would do open parentheses, -12, then close your parentheses, and then hit this x squared button. That'll square it for you. And hit enter, because that gives you positive 144, right? Because if you're squaring -12, that means you're doing -12 times -12, which is positive 144. And then do the bottom. 2 times 4 gives me 8. Bring over my plus 8. And 8 plus 8 gives me 16. So let's simplify this in our calculator. Remember, we would just do whatever's in top divided by whatever's in the bottom. So I'm going to do 144 divided by 16. And it divides evenly. So 144 over 16 does reduce to positive 9. So the second part of this problem is it wants you to do the same thing, except now it wants x to equal -4. So same problem, it's just that I'm replacing these x's with -4. So let's see what that does. So up top, -3 times -4 squared. In bottom, 2 times -4 plus 8. Do what's inside these parentheses first. So I have -3 times -4, which is positive 12 squared. And 12 squared again gives me 144. So I'm equal to 144 again up top. But look what happens in the bottom. You have 2 times -4, which gives you -8. And when I bring over my plus 8, what is that going to give me? I've got -8 plus 8, which gives me 0, right? Here's the thing. When you have a fraction, you can't have a 0 in your denominator, okay? That would tell you that this numerical value is undefined. That's what it's called, because if you tried to put that in your calculator, 144 divided by 0, look what it's going to tell you. Error, divide by 0. That's the error, is you can't divide by 0. So that's why this one, if you end up with a 0 in your denominator, it is undefined. Right, number 3, same thing. So on this one, I have 5x plus 4 over 2x squared plus 15x plus 25. The first thing it wants me to do is find out what this would be when x equals 2. So again, everywhere you see an x, you're going to put a 2. So here, here, and here. All those x's are going to be 2's. And then I'm going to have to follow the order of operations. So up top, I have 5 times 2 plus 4. in the bottom, 2 times 2 squared plus 15 times 2 plus 25. So let's just do the top first. You can kind of just think of them as two separate problems. So just ignore the bottom right now. Let's figure out what the top is. 5 times 2 gives me 10. Bring over the plus 4 to get 14 up top. Now, in the bottom, here, you've got to do this exponent because exponents come before multiplication in the order of operations. Okay, so I have to do the 2 squared first, and 2 squared gives me 4. So this really says 2 times 4 plus 15 times 2 plus 25. So all I've done first on that first step is change that 2 squared to a 4. So let's see, down here I have 2 times 4, which gives me 8, plus 15 times 2 is 30, plus, bring down that 25, and then I'd probably just punch that in my calculator, right? I have 8 plus 30 plus 25, which gives me 63. So I had 14 on top, 63 in the bottom. If you're not sure whether or not that reduces, remember, put it in your calculator just like you see it. So that would be 14 divided by 63. Enter. Math, enter that. So we see here that it does reduce to 2/9. Right, number 3. Same thing, we're going to do x equals -3 this time. So it wants me to change all my x's to -3s. So again, same problem. I'm just replacing the x's with -3. So I have 5 times -3 plus 4 over 5 times -3 squared plus 15 times -3 plus 25. Let's do the top first. So up top, I have 5 times -3, which is -15. Bring over the plus 4. If you would like to punch that in your calculator, go right ahead. -15 plus 4 gives me -11. Now remember, in the bottom, we need to do this exponent first. So -3 squared. Be careful. Remember, when you put something and you square it in your calculator and it's negative, you got to put parentheses around it. So -3 squared actually gives me +9. So I have +9 there. I'm going to drop the rest down. And then do this math. 5 times 9 gives me 45. Now here I've got +15 times -3. When I multiply that, I get -45. Bring down my plus 25. So here, when I'm looking here, 45 minus 45 is 0, but then I'm adding 25 to it. So 0 plus 25 gives me 25. And again, if you are not for sure, type that in your calculator. Let's see, -11 divided by 25 There's my weird decimal, math, enter that. And it still tells you negative 11 over 25, which all that means is that is the simplest form of that. It doesn't reduce at all. Now, remember on number 2, when we replace that x with negative 4 on number 2, remember what it did to this denominator. It turned that denominator to 0, which in turn made that answer be that was undefined. So here's what happens is your denominator turning to 0 is what makes your fraction undefined. So we're going to use that knowledge for 4 through 8. Okay, so let me write that down for you. Okay, the value that makes a fraction undefined is the value that makes the denominator equal to 0, right? When your denominator is 0, that's when your fraction is undefined, because when your denominator is 0, that means you're trying to divide by 0, which you can't do, okay? So to find this value, that's exactly what we're going to do. We're going to set the denominator equal to 0 and then solve whatever that equation is now for the x or the v or whatever letter they're using. Okay, so let's look at number 4. Okay, so first find all the numbers for which the rational expression, and rational expression is just a fancy way to say fraction. So for which the fraction is undefined, we have 17 over 6b. So let's see. On these problems, when you're finding what makes a fraction undefined, you don't care anything about the top. All you care about is the denominator, and what you do is you're going to just set that denominator equal to 0 and then solve it. So if I'm going to solve this for v or get the v by itself, how do I get rid of a 6 that is hooked on? How do we get rid of those hooked on numbers? We divide by them. So now I'm left with v equals, when the zero's in the top of your fraction, it is fine. It's just that 0 over anything is 0. So the number that makes this rational expression undefined just happens to be 0. So that is your answer. So all you would put right here in this top answer, the number for which the rational expression is undefined is, you would just type in 0 right there, because look what happens. If you put in a 0 in where that v was, what happens? You'd have 17 over 6 times 0 is 0, which is that undefined that we're talking about. All right, let's look at number 5. Same thing. V plus 2 over V minus 4. Don't care about the top. I need to find what's going to make this undefined, so I'll set it equal to 0 and solve it for that v. This time to get v by itself, I need to get rid of minus 4. So how do we get rid of minus 4s? We add them, right? If I do it to this side, I have to do it to this side. So here I'll drop down my v. Equals 0 plus 4 is 4. So 4 is the number that will make this one undefined. Right? We're going to keep going with this. Let's look at number 6. On number 6, the problem looks like this. 7x squared over 3x plus 5. So if I'm finding what makes this one undefined, don't care about the top, I'm going to set my denominator equal to 0 and solve it for x. Remember, hooked on numbers go away last, right? So I need to get rid of this plus 5 with a minus 5. So here I have 3x equals 0 minus 5 is negative 5. Now get rid of your hooked on number by dividing. So x equals, that just is a fraction that doesn't reduce, so negative 5/3 is the one that makes that one undefined. Now, let's look at number 7. Number 7, what have we been doing this whole time? Whatever our denominator is, we set it equal to 0 and then get the x by itself. But looking at number 7, I see something different. I see y squared minus 6y in the top over 4. If I'm looking at this, and I set the bottom equal to 0 and tried to solve it for, I guess, y in this case, there is no y, right? I wouldn't be able to get y by itself in that denominator because there wouldn't be a y to get by itself. So if you don't have the y in your denominator, if there's not a variable, then there is not going to be any numbers that are going to make this undefined. So this is when you would check this one. The rational expression is never undefined, because think about this. If I am, just like we were doing at the beginning of class, where we were replacing all the x's with different numbers to see what it did to the fraction. If you're replacing these y's with all these different numbers, this numerator is going to change to all different kinds of things, depending on what you're putting in for the y. But it doesn't matter what you put in for y. What's your denominator always going to be? It's always going to be 4 because you can't change it because there's nothing to plug into down there. So if your denominator is always going to be 4, then it can't ever be 0. Okay, so this one, if there's not the variable in the denominator, then nothing can make that undefined. Okay, number 8. Oh, this one's different. Starting something new here. I thought we were doing the same thing. It says write the expression in lowest terms. Okay, we've done this before. When you're writing it in lowest terms, okay, remember, this is like a division symbol. So if you have 12 divided by 2, that's just going to give you 6, right? Now, what do we do with these exponents? This one, when we are dividing the same bases, remember what that exponent rule is you are going to subtract your exponents here. So if I have x to the 6th over x to the 1st and subtract those exponents, I'm going to be left with x to the 5th. Now, 10 through 13, when we are simplifying these rational expressions, sometimes we'll see stuff like we've seen before, and we'll just do the division and then subtract our exponents for the x's. But sometimes you're going to see multiple terms in the top and multiple terms in the bottom, or you'll see parentheses up top and the bottom. So looking at number 9, you've got s plus 4, s minus 4 in the top. Over s plus 4 squared. Now, think about this. What does s plus 4 squared mean? It means s plus 4, right? So let's, first things first, let's rewrite this with this denominator all the way written out. So I still have s plus 4, s minus 4 in my numerator. In my denominator, if I wrote that all the way out, I'd have s plus 4 twice, right? That's what it would mean if it was squared. So in this one, anytime in the top and the bottom, you have the factors that are the same, you can cancel those, okay? So what I'm talking about is this s plus 4. What is it when somebody is over exactly themselves? Anytime you have the same factor in the top and the bottom, like here and here, it simplifies to a 1, right? So that's why we say it cancels, okay? It's not just going away, it's just turning into a 1. Once you've done all the canceling like that, your answer is just essentially what is left in the top and the bottom. So up top, I'm left with s minus 4. In the bottom, I'm left with s plus 4, and that's your answer. So what you want to see is you want to see factors, things that are multiplied together, okay? Like in these parentheses. If your parentheses next to each other, that means you're being multiplied together and that you could cancel something in the bottom. So I need to see it in its factored form, which is important starting on number 10. simplifying, I see 4y plus 28 over 3y plus 21. So on this one, I see multiple terms in the top and the bottom, and I don't see them in their factored form. You can't just start canceling until you see things that are multiplied together, not things that are added or subtracted. So I can't just start reducing and canceling here. So what you're going to do first, I'll fix it. I'll fix the screen in a minute. So you're going to factor just like we did all in chapter 6, what we just finished last week, all that different factoring comes into play now. So remember, the first thing you're always going to look for, and you kind of think of them as two separate factoring problems. We're going to do the top first and then the bottom. The first kind of factor you always look for, no matter what, is something in common, the greatest common factor. So when I'm looking at top, I'm trying to find something to pull out. So remember, what I like to do is kind of find the smallest number, which is 4. And let's see, how do I multiply to get 4? 4 times 1 or 2 times 2. Okay, and 1 doesn't help me. So the only numbers I'm looking at are 4 and 2, and I'm trying to find the biggest one that also goes into 28. So I'm going to try the 4 first, since it is the biggest one. And again, all I need to do is just say, okay, does 28 divide evenly by 4? Since it's not a decimal, that means it does, which means I can pull a 4 out of both of these. So that's what I'm going to do to factor this. I'm going to pull out the 4, and then remember, in greatest common factor, you're going to put in there what is left. How do you find out what is left? If you pulled the 4 out of both of these, you divide them both by 4. So if I divide this one by 4 and this one by 4, let's see what is left. If I took the 4 out of this first term, all I'm going to be left with is that y. Bring over my plus. 28 divided by 4 gives me 7. So you're done with the top. Do the same thing in the bottom. What goes into 3 and 21? Well, the only option would be 3, right? Because I'd be using 3 times 1 is the only way to multiply to get 3, and 1 doesn't help me. So does 3 go into both of those? And it does. So now I'm going to pull out my 3. Which means I'll divide these both by 3. And see what's left. If I pulled the 3 out of this one, all that'll be left is the y, plus 21 divided by 3 gives me plus 7. So now you have taken care of factoring the top and the bottom. So the second step now is you're just looking for factors that are the same that you're going to be able to cancel. So once I did the factoring, I noticed that I had y plus 7 over y plus 7, so they canceled. So all I'm left with is a 4 in the top and a 3 in the bottom. So it simplifies to 4/3. Okay, use this example. I'm going to put number 11 on the board. It's very similar to this one. And then I'll pause for a second and let y'all have a go at it. So I've got 5a minus 25 over 8a minus 40. Okay, so very similar to that last one. All right, so just like the last one, I'm looking for what's in common. So I'm thinking what goes into 5 and also goes into 25, which would be 5, right? 5 is the only number besides 1 that'll go into both of those. So if you pull out the 5 and then do that division, which means I would divide, I know it's hard to see, I'm going to divide these both by 5. So let's see, if I pull the 5 out of the first term, all I'm left with is A, minus this time, so minus 25 divided by 5 is 5. Let's see, what's the biggest number that goes into 8 and 40? Let's see, 8 times 1 and 4 times 2. Not counting 1, I need to figure out which is the biggest one of those that also goes into 40. So try the biggest number first. So let's see, does 40 divide evenly by 8? So 40 divided by 8. It's not a decimal, which means it does. Which means 8 is the biggest number that'll go into both of these. So I can pull out the 8 and put in parentheses what is left. So if I divide them both by 8, here if I pulled out the 8, I'm just left with A, minus here if I pulled out the 8 or divided by 8, I'm left with 5. So again, once you've done that factoring, then you're looking for factors that can cancel. So the A minus 5s will cancel. So you're just left with a 5 up top and an 8 in the bottom. Right, number 12. Now remember, there are other kinds of factoring besides greatest common factor. Right, there's difference of squares, there's 2 different kinds of trinomials, there's the factoring by grouping. So there's other options also. So we need to keep that in mind. Let's look at number 12. We have s squared minus t squared over s plus t. So let's see, up top, remember you want to factor the top and the bottom before you can do anything else. Look at the top. There's nothing in common, right? So I can't pull anything out. I have an S and a T. So I'm looking for the other, there's only one other kind of factoring that we've gone over when you have 2 terms that you can use, which was difference of perfect squares. So let's look at this and see if it checks the boxes in order for that to be. The first term has to be something squared, which it is. And so is the second term with a minus in the middle, which means this is a difference of perfect squares. So when I factor difference of perfect squares, I'm going to get 2 factors. Whatever you have to multiply together to get s squared goes at the beginning of each of these. So what would that be? What do you multiply the same thing twice to get s squared would be s times s. Then the back of these factors is whatever you multiplied together that's the same thing that gives you this last term. So how do you get t squared? Well, you'll need a t times a t. And when you're doing difference of squares, your signs are always one positive and one negative, and it doesn't matter who comes in front or back. Now, looking at the denominator, I'm looking for something in common. They're not difference of squares. So sometimes there is no factoring to do, right? I can't do anything with just an s plus t. So I'm just going to bring it over. So I do have a common in the top and the bottom, so that s plus t cancels that one. So all you're left with is minus t. All right, last one. (15x squared plus 32x plus 16 over 15x squared minus 8x minus 16. Now remember, you can't just go in and start canceling here. You have to do the factoring part first because you can only cancel things that are multiplied together. If there's a plus or a minus separating you from another term, that means you are not a factor and you can't cancel. So let's see, just ignore the bottom right now, just looking at the top. I'll look for something in common, but I have 15 and 16. There's not anything besides a 1 that's going to go into both of those. Which means, remember this kind of factoring. This is the long kind of trinomial. This is the kind of trinomial where we had to multiply the first number times the last number. So here's what I'm going to do on this one to keep my work organized, because that's going to be important on a problem like this, is to keep everything organized. When I factor this, I'm going to do the work down here, but then I'm going to put my answer after I factor right there. So I just want to see what this is after I factor it. And when you're factoring trinomials, you're always going to end up with 2 factors in parentheses. So now let's do the work down here, and then I'll just put my answer up there. So let's see, if I multiply 15 times 16, I get 240. Now remember, this is when I made my little T-chart. Now, this is where I am looking for 2 things. I'm looking for numbers that multiply to 240, and there's a ton of them. But the pair also has to add to that middle number, that 32. This is when we use that calculator trick in our y equals area. Oops, wrong side. So I'm going to go to my y equals, whatever's in there, I'm going to clear it out. Now, remember the number that comes in here. It's whatever this number right here is. That's the number I'm using. So I'm going to do 240. Now, remember what you do. You do divided by x. Then you go down. You're going to type in the same thing. 240 divided by x again. But remember, in the second y, you're going to put in a plus x. So now what we want to see is the table of this. So hit the second button and then come over here where it says table and hit that button. I'm looking in this last column for that middle number, which is 32. So I'm going down. Oops. Looking for 32. There's the 32. So here, those are the numbers that I'm going to use, a positive 12 and a positive 20. Now remember, the next step is you're going to make fractions with this being your denominator, just without the squared. So I'm going to put 15x under both of these. And then I'm going to reduce these fractions. So the first fraction is 12 over 15. So just go to your main page of your calculator and reduce that. So 12 divided by 15, 0.8, but math, enter that so we can see it as a fraction. 4/3. I mean 4/5, sorry. 4/5 So positive 4 over 5 is what that fraction reduces to. Do the same thing to your other fraction. So I've got 20 divided by 15. Okay, so it's another decimal. So just math enter that to see that that one reduces to 4/3. So positive 4/3. Now remember what we did with this. That is where your factors came from. The bottom of the fraction first, so 5x. Then the top, plus 4. Same thing on this one, 3x plus 4. So where does this go? Where did this come from? Well, it's where I factored this top numerator and it gave me this. So remember what I said what I was going to do when I got my answers. I was just going to put them here. So I've got 5x plus 4 and 3x plus 4 up top. Then I'm going to do the same thing in the bottom, which means I'm also going to get another thing like this in the bottom. So I'll just multiply here, do the same kind of factoring. 15 times, be careful with your sign, because it's negative 16 this time. So 15 times negative 16 gives you negative 240 this time, right? So when I go to my y equals this time, I'm putting in negative 240 in my y equals. So just clear it out again. This time I'm putting in negative 240 divided by x. Go down and do the same thing, negative 240. Oops, 0. Divided by x and plus x. Now go to your table. So second table. Looking in my last column, this time what am I looking for? What's my middle number? Negative 8 in my last column. So I see it down here at the bottom. There's my negative 8, which means I need to use negative 20 and positive 12. So negative 20, positive 12, put them over 15x. Reduce your fraction. So let's see. The first fraction I have is negative 20 over 15. So negative 20 over 15. It's a decimal again, so math enter that, which will give me negative 4/3. So negative 4 over 3. And then do the 12 over 15. So 12 divided by 15. It's a decimal again. So math enter that to get 4/5. So this one reduces to positive 4 over 5. So let's see what these factors are. So the bottom of my fraction is 3x. The top this time is minus 4. And this one is positive 5x plus 4. So those are the factors of the denominator. So that's where I'm going to put those. In the factored form of this denominator, I'm going to have 3x minus 4, 5x plus 4. So let's see, I don't have any of the factors that are the same in the top and the bottom. Everything the same. So this 5x plus 4 and that one will cancel. These are not the same, right? That's 3x plus 4. That's 3x minus 4. So that's what's left. In the top, I have 3x plus 4. In the bottom, I have 3x minus 4. Now remember, those 3x's can't cancel because they're not factored. If you have a plus or a minus separating you from the next number, that means you are not a factor and you cannot cancel. Okay? You have to be multiplied times something else fully to be able to do that. Since these 3x's have a plus and a minus separating them from the next number, that means they can't cancel. So that's why you have 3x plus 4 in the top and 3x minus 4 in the bottom. Okay? So we are going to stop